Hey guys, so we're gonna touch on nomenclature. Before we get into that, these unfortunately are polyatomic ions that you have to memorize. They're gonna be used throughout the whole course. And so if you see like the compound iron 2 nitrate, you've gotta know what nitrate is. These are not just elements on the periodic table. These are like compounds that have come together covalently and forming what we call a polyatomic ion. So you have to be able to memorize these. So on your sheet, I want you guys to take a few minutes, work with your group, and write down each form of the polyatomic ions. So for example, nitrate, if you look at it in you can search it up on Google or whatnot, okay? So I look at nitrate, I type that in my computer, and I should notice that nitrate is NO3 with a -1 charge. So these polyatomic ions are going to be compounds put together with an outlying charge. You must know the compound and the charge, and what we're done is we've broken up into a couple of different quizzes. So for our first quiz, we have on Thursday a polyatomic ion quiz on everything that has a -2 charge. So everything that you find here that has a -2 charge, you are going to have a quiz on that on Thursday. If you have questions about that, you can ask me on Wednesday. The Friday quiz is going to be everything that has a -1 charge. So you see nitrate would be a part of that quiz. And then on Monday, the 18th, that polyatomic ion quiz is going to be on everything else. That's not a -2 or not a -1 charge. So take a few minutes with your group, find all of these polyatomic ions, write them down, make sure you have them correct, and study those and get ready for your quizzes. After we do that, we got to get into nomenclature. So the purpose of us being able to determine those polyatomic ions is they're going to be used in the nomenclature a little bit. So we have to know the difference between an ionic and a covalent or molecular compound. The way we name ionic compounds is different from how we name covalent compounds. Covalent and molecular, that word is interchangeable, so realize that you could use either or. Most of the time in AP, you're actually going to see the word molecular instead of covalent. So we name ionic and covalent compounds differently because they are put together differently. Ionic bonds are formed by electrons being transferred, and covalent bonds are formed by electrons being shared. So, how can I tell the difference if I have an ionic or a covalent bond? It's all based upon the components that make that bond. If you have a metal plus a non-metal, then that is going to create an ionic bond. If you have two non-metals come together, or a metalloid and a non-metal, that is going to create a covalent bond. So you might be like, okay, that's cool, but how do I know if things are a metal or a non-metal? What you have to do is look at the periodic table. I wish I had one handy for you. Let me grab one. So on this periodic table, there is a staircase that is formed, right? That staircase starts here and it goes throughout. Everything to the left of the staircase is a metal. Everything to the right of the staircase is a non-metal, and everything along that staircase is called a metalloid. So when you get into the class and you look at the shower curtain over by the couch on the thing, anything that is blue and yellow, that is classified as a metal. Anything that is pink, that is classified as a non-metal, and anything that's green over there on the shower curtain is classified as a metalloid. So if I look at a compound and it has a metal, something to the left of the periodic table, and a non-metal, something to the right of the periodic table together, it's creating an ionic bond. Two non-metals, or a metalloid and a non-metal, is creating a covalent bond. So the very first thing you have to do is identify what type of bond you have And then based upon that bond, you can then figure out the rules of naming or writing those. So if we have a covalent compound or a molecular compound, remember this is non-metal or metalloid nonmetal combination of things, then what you are going to do is use prefixes. So you see how all of these pairs are nonmetals because they're to the right of the periodic table. I give the prefix according to what it is. So notice something else that's happening. Every ending here is IDE, I-D-E. So for this one, we have nitrogen monoxide. The mon comes from the prefix meaning one, because I just see one oxygen there. This one, however, is nitrogen dioxide. The reason why it is di is because I see the subscript 2 for the oxygen. And then I have dinitrogen trioxide. So dinitrogen trioxide, right? So you see the example on how all of these prefixes are going through there. When I see a covalent compound or a molecular compound, again, two nonmetals, I look at how many I have of each, and then I give the prefixes to give the name. So that's pretty straightforward. If I were to take the name and write the formula, I just do the opposite. 2 nitrogens, 3 oxygens, and that's my formula. So there are a couple of practice. So again, these are just molecular compounds. So you're using the prefixes here. I want you with your group to be able to write out the compounds of all of those using those prefixes. Now what's a little bit harder, not terribly hard, but a little bit harder is naming ionic compounds. So when we name ionic compounds, we do not use the prefixes at all, okay? So prefixes are only for covalent or molecular compounds. Again, how do I know if it's an ionic compound? We're looking at a metal to the left of the periodic table, non-metal to the right of the periodic table combination of things. So for instance, you see how calcium, if you find it on the periodic table, is to the left, oxygen, find it on the periodic table is on the right. So when those come together, they create ionic compounds because they're transferring electrons. We do not use prefixes for that. So how do we name these instead? We give the cation name first. Now the cation is the thing that is positively charged. It is your metal, all right? Your metals are positively charged. That is represented and known as a cation. Your anion is the negatively charged thing, and those are going to be your nonmetals. So we give the name of the cation first, we give the name of the anion secondly, and we change our ending to "ide" if it is binary, and we'll talk about that in just a second. Okay, so here's an example. Strontium chloride. Notice how I'm not using the prefixes. I don't care that there's 2 chlorines there. I'm just giving its name strontium chloride. For this one, this is cobalt, and notice how it has parentheses beside it. When you see parentheses, that is a Roman numeral that's represented if there is more than one possible charge. Well, you might be asking, well, how do I know if there's more than one possible charge or not? If your metal is in what we call a D block right here, so this D block is the one in the center. If again, you're looking at the periodic table in the classroom, it is your yellow stuff on the periodic table. That's my shower curtain over by the couch. These are called transition metals. And the reason why they're called transition metals is because their charge can change. They don't have a set charge like other metals and nonmetals. So we use the Roman numeral to represent what that thing's charge is. So for instance here, we have cobalt, 2 Roman numeral chloride. So you might be asking yourself, well, how do I know it's cobalt 2? Why is it not cobalt 1? Why is it not cobalt 3? How I figure out the ending is I have to know the charge of chlorine first. So chlorine, if you look here, everything in the second to last column has a -1 charge. This is column 17, or group 17 is what we represent it as. Everything in group 16 are -2 charges. Everything in group 15 is -3 charges. For the hydrogen, group 1, all of that is +1 charge. Group 2, +2 charge. And then over here in group 13, those are +3 charges. Hopefully, if you did the summer assignment, you had that periodic table where you labeled it, your metals and nonmetals and your charges there. And so that's going to be able to make this so much easier. You can pull that out and work on that, work with that periodic table that you have today. All right, so chlorine here has a -1 charge. Why? Because it's in this group that all has -1 charge. So since the chlorine has a -1 charge, do you see how I had to have 2 chlorines total to be able to balance out my charges? That should be a lowercase o, so COCl2. All right, so I had 2 chlorines total, which makes this total charge -2. So where I'm getting this number, -1 is the charge of 1 chlorine times 2 of them gives me an overall charge of -2. So what that means is this cobalt has to be a +2 charge, because whenever you're creating an ionic compound, you want to be able to add these 2 numbers equal to make it 0. That means we're neutralizing that compound. So since cobalt is a 2+ charge, we have to tell the reader that it is a +2 charge since its metal can change. So we're putting that as a Roman numeral in parentheses beside it, okay? Now you only have to do the Roman numeral in the parentheses if you have a transition metal, because cobalt is in this D block, this block right here in the center. That is why you have to do that. Now, for this one here, calcium oxide, calcium is not a transition metal, so you see it does not need those Roman numerals. You just give the name of the cation. The cation is calcium. Give the name of the nonmetal, that is oxygen, and you give it an IDE ending. Sometimes your compound will have a polyatomic ion in there. So remember, that's the beginning of the video where our polyatomic ions that we have to memorize. If there is a polyatomic ion that is in your ionic compound, then we just give the name of the polyatomic ion. We do not change our endings to "ide." Let me give you an example of this one. So let's say we have NaNO3. First of all, how do I know this is an ionic compound? Na is a metal. NO3 is a combination of nonmetals. So therefore, this is an ionic compound. What do we do for ionic compounds? We give the name of the cation. So this is sodium. We check to see if it's a transition metal. It is not a transition metal, so we do not have to use those parentheses. So now we give the name of the ending anion. This anion is not just a single element, it's a polyatomic ion. So I'm going to give the name of that polyatomic ion and do not change its ending. So this would be sodium nitrate, because that is what that polyatomic ion is called. As opposed to this, Na3N, okay? This also is an ionic compound because it's a metal with a nonmetal. So what do? Give the name of the first cation, sodium, give the name of my anion, but because this is not a polyatomic ion, then I end with I. So this would be sodium nitride for that name. Now, this is how we name them. What if I wanted to write its formula? What I do there, let's use this calcium oxide as an example. So I have the name calcium oxide. I want to write its formula. So what I have to do is find calcium's charge, located on the periodic table. Because it's in column 2, that means it has a +2 charge. So that's where that's coming from. Oxygen, located on the periodic table. Because it is in column 16, it has a -2 charge. So that's where this is coming from. Now my whole goal is to create these and put subscripts down to where these charges cancel out or neutralize, kind of like what we were talking about here with the cobalt. So how many calciums, how many oxygens do I need to make them add together and equal to 0? Hopefully you're telling yourself that I just need 1 calcium and 1 oxygen because +2 plus -2 is equal to 0 already. Now, let's compare this to the compound calcium chloride. Okay, so calcium chloride. So here's what I do when I'm writing the formula. Calcium, figure out its charge. Calcium is a 2+ charge. Chlorine, figure out its charge. It's a -1 because of where it's at. Now, does 2 plus -1 equal 0? The answer is no. So you ask yourselves, well, how many chlorines and how many calciums do I need to be able to neutralize itself, cancel out to equal 0? If I put 2 chlorines here, do you see how -1 and -1 cancels out +2? So the way I'm going to write this compound is this, CaCl2. This 2 that I'm representing right there is called a subscript, and we'll talk more about that as we get through that, okay? So this is how we write formulas. This is how we name ionic compounds. Pay attention to if you have a Roman numeral or if you have a transition metal, that's the only time you use those Roman numerals. Notice for ionic compounds, again, I am not using the prefixes for how many there are. That leads us into practice. So you guys are going to complete this practice. You are writing the formula for each of these. Remember, these Roman numerals are telling you the charge of these transition metals. This is where you need to know some of your polyatomic ions, so make sure you're aware of that. Then, for mixed nomenclature, what we're doing here is we're having to first determine what type of bonding that we have. Is this an ionic compound or is this a covalent compound? If we have an ionic compound, we use the ionic rules. If we have a covalent or a molecular compound, we use the covalent or molecular rules instead. So try not to get these mixed up. The very first thing you have to do is decide what type of compound is this first. So let's look at this compound here. We have a V and we have an O, all right? So if you look at your periodic table, the V is right around here, number 23 on the periodic table. That V is a metal, and more importantly, it is a transition metal. So Since this first thing listed is a metal, that means that this is going to be an ionic compound. So let's first identify that. Step one. Number one, we have an ionic compound. So again, let's review what our rule for an ionic compound is. We give the name of the first element. So this first element here is known as vanadium. Then I double check to see if this is a transition metal or not. Because of where it's located on the periodic table, it is a transition metal. So what I like to do is I put Roman numerals there and leave some space, and I'll come back at the end to figure out what that Roman numeral is. Then I give the name of the ending. That is just oxygen. It's not a polyatomic ion, so my ending is going to be oxide. Notice I am not putting prefixes here. Why? Because it's not a covalent compound. Covalent compounds are the only time when I use the prefixes. So now all that we have left here is for us to figure out what this Roman numeral is. So I go back here, V2O5, okay? What is oxygen's charge? Because of where it's at on the periodic table, it has a charge of -2. How many oxygens do I have total? -2 times 5 gives me -10 total. So what that means is that some number plus -10 has to equal 0. What is this number? It is +10. Now, is that +10 for just one vanadium? Hopefully you see, no, there's 2 of them. So 10 divided by 2 tells me that this charge is +5. So notice my process that I'm doing here. My charge times my subscript is equal to total charge. Total charge divided by subscript is equal to the charge of that particular thing. So vanadium, because it's a +5, is going to get the Roman numeral 5 right there. Hopefully that's making sense to you guys. If you're still having trouble with this, I promise we can work on this Wednesday as well. Let's do number 2 together, all right? So for number 2, we have O and F. O is a nonmetal, F is also a nonmetal. So because we have 2 nonmetals coming together, that makes this a covalent or a molecular compound. Now, this is the easy part. Because it's covalent or molecular, we do get to use the prefixes. So how many oxygens do I have? Just one, so I say oxygen. How many fluorines do I have? 2, so that prefix we use is di, and then I give the ending IDE. So oxygen difluoride is the name for number 2. So I want you guys to try to work with your group to determine 3, 4, and 5 there. And then what you have is some formula writing for dinitrogen tetraoxide. Let's do 2 of these together. So this is just writing the formula. The other one was naming it. So we'll do 1 and 2 together in this one. So what is the formula of dinitrogen tetraoxide? So again, what is my very first rule? My very first rule is to determine if it's ionic or covalent. Remember, covalent uses prefixes, ionic does not. So we have dinitrogen tetraoxide. So that tells me that this is a covalent or molecular compound. So when I have a covalent or molecular compound, I just write it according to its prefixes. So dinitrogen would be dinitrogen. Tetraoxide would be tetraoxide. And this would be our covalent or molecular compound for number 1. For number 2, let's evaluate this one. We have cobalt to chloride. So we figure out first if this is ionic or covalent. I don't see any prefixes, and I see a metal with a Roman numeral. So that means that this is going to be an ionic compound. Now, when we write an ionic compound, we look at the charges, we cancel them out. So our subscripts are not coming from prefixes like this, but our subscripts are coming from balancing out my charges. So let's write down cobalt. Cobalt is here. Since it's a transition metal, it doesn't have a set charge, so I pull its charge from the Roman numeral. This is a +2. And then chloride comes from chlorine. Because of where it's at in the column, it has a -1 charge. So I'm asking myself, how many chlorines do I need to have to cancel out with cobalt, or vice versa? Because this is a +2 charge and this is only a -1, I need 2 chlorines to be able to balance that out. So where I write my subscripts down is I write how many cobalts I see, how many chlorides I see, Cl2. Notice when I'm writing down an ionic compound from my charges, because these charges have canceled each other out, I do not include those charges anymore in that compound. So this is how I evaluate a covalent or molecular compound versus an ionic compound, and from there you can write down its formula. So if you struggle with this a little bit, don't fret, you should be fine. We will work on that more on Wednesday and Thursday if we need to. Try to tackle with your group the rest of these, and then after you finish that, you are going to work through this practice that is mixed nomenclature there. So by the time that you come to class, there's another slide of the mixed nomenclature there. So by the time you get to class on Wednesday, I would like for you to have all the significant figure practice done, as well as all of the nomenclature practice. Wednesday, we'll come together, we'll do the density lab, I'll fix whatever questions or whatever confusion you have with the nomenclature, and then on Thursday, we'll be in a good place to be able to start reactions. So I hope this was helpful. Feel free to write down questions that you have or things that we need to talk about on Wednesday to be able to get you guys to feel good about nomenclature. If not, I hope you have a good day and get ready for that lab the next day.